All right, everyone. So in this segment, we are going to see the implementation of queue data structure. So here also we're going to see two type of implementation, array-based implementation and linked list-based implementation. So in each implementation, we are going to, by implementation means we are going to see the definition, the class definition of the list, all right, and the definition of each of the functionalities. By functionalities means we talk about the functionality we are going to implement here, NQ, DQ, peak, and is empty. All right. So, and for each of the operation, we are going to see actually what will be the runtime for each of the operation in each different implementation. So let's see how we can implement our queue data structure using array-based implementation. All right. So by array-based means we're not going to use static array because static array has the disadvantage like for static array, we have to always mention the size of the array, okay, during the compile time. So that's why we're going to use the dynamic array. So the dynamic array means during the runtime, we can decide about what will be the what will be the size of the array. And using the dynamic array, that's how we can actually resize the size of the queue. For example, if you have a queue with size 50, but you have an additional item, okay, that exceeds the maximum size, in that case, you will have the flexibility to resize your array. All right. All right. So in the dynamic array-based implementation, it will look also like linked list. Sorry, it will also look like a list implementation that we saw, that was actually like the array-based implementation of the list data structure. Okay, so a queue is also a list data structure, but the difference is only the insertion and the deletion always is going to maintain a specific order, which is the first in, first uh, first out. Okay, so in this implementation, you can see that this is our going to be the class definition of the queue. All right, so we'll have an array. All right, so we are implementing this list or queue using the dynamic array. So we'll have this array. So each list has to have a maximum size. Maximum size means the current size of the queue. Okay, the current size of the queue, maximum current size of the queue. All right, the end of queue is just a flag or just an integer value by which we are going to keep track which one is the last item of the queue. All right, for example, here let's see we are having a queue of maximum size 7. Okay, so when we'll declare the queue, okay, we are declaring the queue with maximum size 7. It can have maximum 7 items in this queue. So let's see the item we are going to insert: 10, 7, 5, and 9. Okay, so the first item we are going to insert 10. The second item 7 will be inserted at the end of 7. Third item 5, 9. So each time we are going to maintain the end of the queue. End of queue is going to keep track of the last item in the queue. Okay. So if there is only one item 10, so end of queue, I'm just writing the shortcut name, end of queue will be 0. Okay. By using the index 0, we'll know that 10 is our last item. All right. All right. So when we'll insert 7, so end of queue will be 1. So for example, in this example here 9 is our last item, so end of queue is 3. All right. So initialization. All right. So when we'll initialize our first queue, we are going to initialize with a maximum size. All right. So that will create an array, create a dynamic array with the given size. All right. Initialize maximum size with the maximum with the size value. All right, and the end of queue will be -1. That means it's just an empty list. So how do we know that the list is empty, means the queue is empty? By checking the value of end of queue. So if end of queue is -1, we'll know that it's an empty queue. All right. So how do we insert? Okay, insert means in queue, insert means in queue. In queue, that will give a value. All right, so that will give a value and we're going to insert the data at the end of the queue. All right, so it is actually same as inserting at the end. All right, so for example, like if at the current stage you have the end of queue index 4. All right, so what does that mean? You have a we want to insert a value in queue. Let's see, we have 10 here. Let's see, we are going to insert 12, okay, in this queue. So that means actually we are going to insert at the end of the list. Now how do we know which is what is our last index in the queue? By using the end of queue value. So here end of queue value is 4. That means in this array, okay, we have to insert the value at the index 5. Okay, looks like a order of 1 operation. Okay, so this is actually this is the statement by which we are inserting the value at the end of the list. All right, so if end of queue is 4, we are going to insert at the index of 5 plus plus end of queue. Okay, we're just inserting at the end. All right, so this one is an order of 1 operation, but the only thing here is that we're using a array based implementation. Okay, so whenever there is an array, all right, so whether it's a dynamic array or static array, it is going to actually reserve a space in our memory. All right, now reserve a fixed space. So let's say we have a queue with maximum size 10. All right, now we already have 10 items in the queue. Now we are trying to insert the 11th item in this queue. Okay, so we do not want our application, we do not want our list to say you that, okay, I cannot insert any more item in the list. Okay, we want to have this flexibility. So what we are going to do, if when we are going to insert an item, if it exceeds the maximum size, we want to resize the queue. All right, and by resizing means it's same as like our list implementation. Resizing means it is going to double the size of the array. For example, if the current size is 10, it is going to declare another array. Okay, it is going to dynamically create another array of size 20. All right, then copy all of the items from here to here. Okay, copy all of the items from here to here. Okay, and then insert the last item from the end of the list. All right, so this resize, the function of resize is here. You can see that resizing means we are going to declare a new array. All right, and with the double size of our current size, and we are going to copy all the values from our old array to the new array. Okay, all right, then we can keep inserting our items, new items at the end of the list or end of the queue. So the resize has the operation. This resize has a operation that takes order of n runtime. Why is this is order of n? Because actually when we declare a new array, we have to copy all of the items from the old array to the new array, and we are doing that one by one. All right, and if it has a 10 value, we are actually like, if it has a 9 value, if the size is, sorry, not 9, if it has a n value, if the size is n, we are going to copy all of the n items one by one from old array to the new array. So that's why the runtime in big O notation is the order of n. All right, so in best case the runtime is order of 1 for the insertion, but in worst case, the worst case, if we trying to insert an item which exceeds the maximum size. All right, then this is our worst case, and in worst case the runtime is order of n. All right, now let's talk about dequeue. So in DQ operation means so in DQ operation, we are going to always pick the first item from the queue. So in this implementation, the first item will be always at the index 0. Okay. So the first item will be always in the index 0. Okay. So we are going to pick the first item from the queue. So first item of the queue means we are going to delete the first item from the queue. Now what happens when we delete the first item on the queue? So we have to actually shift all the items, all right, from the array. So now when we delete the first item from the array, okay, so deletion is simple. We're going to just delete this item, all right. That means we have to shift all the items from the array. So index 1 will be at the index 0, index 2 will be in the index 1, index 3 will be at the index 2. Means I'm trying to say that the value at the index 1 will be at the index 0, value from index 2 will be at the index 9, index 1, the value from index 3 will be at the index 2. That means we're shifting all the value, okay, from the array. So you can see that if the end of queue is greater than or equal to 0, okay, means there are actually at least some items in the queue. Okay, so this is saying that there are some items in the queue. So we're going to return this value array 0. Okay, so this is our item that we are picking. All right. So then what we are doing, we are going to start from our index 0 to at the end of the queue. All right. And we are going to keep the modification like that. Array index will be equals to array index plus 1. Okay. So array 1 means the array 1 will be the value of array 0. Array 2 will be the value of array 1. Okay. Array 3 will be the value of our array 2. All right. And end of queue also we have to modify the value of end of queue. All right, because like, so let's say this was our end of queue. Now index 9 will be our end of queue, right? So we have to decrement the value with 1. All right. All right, so that's actually our DQ. So DQ means actually we are deleting the value from the front of the array, okay, with the index 0, but we have to shift all of the items. Okay, so and this shifting, you can see that we have to shift all of the items, means it's the order of n runtime. Okay, if the number of items in array is n, all right, so it is going to need n operation. So the runtime is order of n. All right. So let's think about our runtime of each of the operation. Enqueue takes order of n runtime due to the resizing. Okay, so this is the runtime of our worst case runtime. So best case is order of 1, but this is our best case. But in worst case, the runtime is order of n. So DQ is always order of n in both worst and best case. Okay. Peak means actually we want to look at the front of the array. So it just we're going to see the value which is at the index 0. Okay, so we're going to just look at the value which is at the index 0. So this is just a 1 operation, order of 1. Is empty is also order of 1 if end of queue equals to -1, means there is no value in the queue. Okay, then our queue is, we know that our queue is empty. So that's also a order of 1 runtime. All right. Now looks like actually the array based implementation, both NQ and DQ takes order of n. All right. So if we need a lot of NQ and DQ operation, all right, in that case actually it is going to take, in each case it is going to take order of n runtime. So as we said in our earlier discussion, preferably we want to implement it using order of 1 runtime. All right. So next we are going to see linked list based implementation, and we are going to look at that whether we can make the implementation better. Means if we find a better implementation, means a better efficient algorithm for the NQ and DQ operation. All right.